Unit 1 is about the scientific process and thinking. It covers what we call GLI 31, 32, and 25. Our first objective, or our learning target, is to list and define each step of the scientific method in order. So this leads us to the next question. What is the scientific method? What is it? Well, first of all, science is a way of thinking. And please, you have to understand that it's not only just science way of thinking, but this is what scientists kind of go about, or a process they use to solve problems. It's sometimes called organized common sense, because as you go through the scientific method, it is really common sense. There's a series of steps that you do it probably every day without even thinking about it. Um, so, which leads us to the next thing. Think about it. A lot of science seems a contradiction in common sense. Take, for example, the Earth. You know, imagine 200, 300 years ago when they said, "Hey, the Earth is round." Well, common sense tells you, no, it's flat. I mean, look. You look across the horizon, and you see it's flat. But we actually know that the Earth is actually round. We know that now today. So, what does that do to our notion that science is organized common sense? Well, how about this? Science is more of organized curiosity. And how do we organize this curiosity? Well, we use the scientific method. And all scientists do this. Now, depending on what they're studying, they apply the scientific method a little bit differently. But they all try basically to follow the same series of steps. And then, of course, what is the scientific method? A plan of organizing an investigation is what it really is. The scientific method involves a series of steps that are used to investigate a natural occurrence. Of course, that's what science is. Science is the study of natural things. So that scientific method is the steps that we use to solve problems and we observe in nature. The scientific method is, here are the steps. Number one, you got to identify a problem or a question. Second step is gather and use background information. This is not always the funnest step, but it's real important so that step number three, when you formulate a hypothesis, you're formulating something that's based on background information. You're not just making a guess, like plants are green because aliens came down and painted them, that kind of thing. Next is to perform an experiment to test your hypothesis. Number five is to collect and analyze data as you're running. Now, a lot of books will have step four to perform an experiment, and five together, because when you're doing an experiment and you're performing the experiment, you are also at the same time collecting and analyzing data. They're not two separate things so much. And then the last is to draw a valid conclusion based on what you saw from your data and your experiment. So let's look at these steps in more detail. The first one, problem or question. You're going to develop a question or a problem that can be solved through experimentation. This is important. When people come up with these problems, they got to make sure that, hey, can I, or question, can I solve this through experimentation? Gather and use background information. This is important in the fact that, a lot of times scientists, professional scientists, if they're working on a problem, a lot of times, they're under a time constraint. They want to get this, problem solved as quickly as possible. And so they'll go and do some background information, get as much information as they can about their subject. This saves them time and money in the fact that if some scientist has done the same experiment or is, working on the same kind of thing, they don't have to repeat something that the scientist says, hey, this doesn't work. Yes, think about medicine. There's one that comes to my mind. We're trying to find a cure for cancer. Well, we don't want all these scientists doing the same experiment and coming up with results that don't cure cancer. We need them to share that information so that they say, okay, this doesn't work. Let's try something else. And so that's why gathering and using background information is so important. The next step, do you remember what the next step is? Formulate a hypothesis. This is a prediction because of an answer to your problem or question. After you do some background information, you've got to have an idea of what you think your results are going to be. And an example here is, if soil temperatures rise, then plant growth will increase. Now, if you've done step 2, you're going to research, the effects of soil temperature on plant growth. So you're going to have an idea, hopefully, whether this is going to work or not. And you might even see somebody else has done it with certain types of plants. And for example, people may have done this with geraniums, and they've tried to grow geraniums in different temperatures of soil and see what the results are. And they tell you, and they show you that, and they tell you that. You say, hey, look, that's pretty cool. Maybe I'll do it with cactuses, or I'll do it with dandelions, or something like that. And so you'll have an idea based on what they did. What will happen? What temperature may be the optimum for plant growth, if there is one. The next thing is to perform the experiment. You're going to develop and follow a procedure, which includes a detailed materials list. Here is another important part. The outcome must be measurable. It's just like you don't want it to be so much based on someone's opinion, because that's hard to what we call qualify, or a lot of this with the scientific methods, you want somebody else to be able to repeat your experiment and get the same results. Well, if it's kind of based on your opinion, then the plant was large. What is large? Everybody's has different notions. Large might be different, so it needs to be something you can measure. Then you're going to collect and analyze data. Now, like I said before, this is happening at the same time as step 4, which is run the experiment. Now here, when you collect and analyze your data, modify the procedure if needed. Sometimes if something's not working or something like that, you may have to modify your procedure to get some results. And then you're going to keep, from those results, then what you might want to do is, modify it. Let's say, for example, the growing of the plant in different temperatures of soil. Well, when you start out, you may have extreme temperatures. For example, you may have soil that is very, very hot, that you keep in an oven or keep it in a very a warm place, and it's very hot. Then you have like room temperature soil, and then you may have soil that you keep in a freezer. So we're talking about very different temperatures. And as your results, you may find one particular temperature of those extremes is growing more than the other two. Well, then you say, okay, well, let's limit the field down. Now let's maybe not go as cold and maybe not go as hot, and start to shrink it down to get more of a finer pinpoint of what is the optimum temperature of the soil. And you keep doing that over and over again. Eventually you may even change the soil maybe by 5 degrees to see what is the optimum temperature specifically. Because if you do it way, from extreme cold and extreme hot and in the middle, there's such a large gap that you really don't know the real specific optimum temperature would be. So if you shrink it down a little bit and get closer and closer and have the temperatures at a smaller varying degree, then you're going to be able to be more accurate with your pinpointing of which temperature is the optimal. Again, you want to confirm these results by retesting and include tables, graphs, and photographs. Then draw valid conclusions. Include a statement that accepts or rejects your hypothesis. We'll talk more about drawing conclusions. We're going to be writing those later on in class. But just understand that you're going to draw a valid conclusion from your results, and you need to link it back to your hypothesis. Now, can you remember all 6 steps? Remember step 1? Come up with a question or a problem. Step 2, find background information or do your background research. Step 3, formulate a hypothesis. Step 4, run your experiments to test that hypothesis. Step 5, which is going to be in conjunction with step 4, collect and analyze your data. And the last step is to